Hello, my name is Matthew Kwan, and today I'm going to demonstrate to you how to do problem number 9 on non-kappa problem set 2 called multiple layer refraction. Now, I haven't drawn the diagram with the beam of light yet because I figured for demonstrating this problem, I'm going to go ahead and draw a simpler diagram that gives you a general idea of what each refraction is going to look like, and also to somewhat reduce the tediousness of this problem. Now, we are going to use the disk method. We're going to, as I mentioned just now, we're going to draw a simplified diagram, gather any information the problem gives us, and any that we know ourselves, see how they link together, and use that to solve the problem, and then check our work. Although, as you will see, this problem is 2 parts, and the second part, done correctly, does serve to, for the most part, check the first part. Now, what do we know about refraction? We do know that the formula for refraction goes something like this. You have an index multiplied by the sine of an angle, and then another index multiplied by the sine of another angle. And these angles both refer to an angle from the normal. And as I draw the simplified diagram, you'll see what I mean. Now, the normal can be expressed just as a vertical dashed line. And generally, as light travels here and becomes refracted, just imagine it's refracted by an arbitrary angle. These angles here, these will be the angles from the normal. Now, the indices of refraction will essentially control this side of the vertical line. So for this situation, for theta 1, n1 would determine the values going in, or at least a portion of the values going in, and n2 will determine the portion of the values going back out. And this will make more sense to you once we actually begin the problem. Now, the information we are given about the problem, we are actually given several indices. We are given n1, n2, n3, and n4. So what you essentially have, or for the purposes of solving this problem, you're going to be basically applying this general idea 4 times, or more accurately, at least for the first portion, 3 times, because you're going to be jumping between the different layers, with each layer having its own index. So you'll be jumping between n1 and n2, n2 to n3, and then n3 to n4. So 3 jumps. You're going to be using this equation 3 times. And as you've probably already guessed, if you want to answer this problem correctly, you'll have to follow along carefully and make absolute certain you don't mess up in between, because if you mess up near the beginning, it's going to change your final answer, sometimes by a lot. Now, the problem gives us n1 as 1.61, n2 as 1.41, n3 as 1.18, and n4 as plain old 1.00. Now, all of these are just the initial information. This problem does have 2 portions, and the first portion gives us even more information. It asks us, given theta 1 is equal to 29.5, what is the angle theta 2 of the emerging beam? Now, real quick, I'm going to just address some slight confusion you may have just gotten upon how this corresponds to our diagram. The diagram given to us all on kappa does possess all the layers. And according to this diagram that I created here, theta 1 is obviously here and theta 2 is here. But these do not directly correspond to the thetas I have listed here. Theta 1 does to an extent correspond. It is the initial beam. However, theta 2 in this instance does not refer to the angle coming out, essentially coming out the other side of the normal. Instead, it refers to the final beam, as in the beam that emerges after going through all 4 layers, each corresponding to an index. So you could think of this as theta 4, and if it helps, that's how you could label it. But for the purposes of this problem, and just to essentially minimize its scale, you can basically apply this 4 times, but also think of this as a simplification of what you're going to do for the problem as a whole. Essentially, you could take this dashed vertical normal and essentially create 3 more of these. You can imagine this one vertical here is a representation of 3 vertical normal lines with the indices being changed in between. Now, we do know that N1, our first index, is 1.61. So that will be, applying the equation I've written here, that will be our initial index. And then our first angle is a given. And now we're going to be jumping. We're going to go on our first jump. So if I were to label these jumps, let's say this is jump A, this is jump B, and this is jump C, you could think of this as jump A. Now, since we're jumping from N1 to N2, and given N1, the initial index, is 1.61, logically we can see that N2 is 1.41. So we put that here. And then we find our theta. Now, this goes hand in hand with what I mentioned earlier. This, by technicality, is not the theta 2 we are looking for. It is simply our next theta on our way to theta 2. And the way that I did this to make it easier for me to understand is I labeled this as theta 1.1. So we are approaching 2, but we're not quite there yet. And once we plug these values into the calculator, you will see that theta 1.1 is approximately 34.2 degrees. Let me just adjust the camera. Now, we are currently in layer 2. We are in the layer that corresponds to the index N2. On our next jump, we'll be jumping from N2 to N3. So this will be our jump B. Now, we are no longer using the index of 1.61. That was for the first layer. At the moment, we are in the second layer. That would be here. So for our initial index this time, we will be using N2 as our initial index. And as our angle, we are going to be using the one we just calculated, 34.2. And since we are jumping to index 3, we will be using, I'll just adjust this, we will be using the value for index 3 on our next jump. And in keeping with our earlier, I'll call it a protocol, we will be labeling this 1.2 because we still got jumps to go. We are not quite at theta 2 yet. And if you plug these values in to a calculator, you will get 42.2 as our approximate theta 1.2 value. And now we'll be jumping from the layer corresponding to index 3 to the layer corresponding to index N4. And that will be jump C. Now, remember, index 4 is just 1, and you'll see how that plays into our next procedure. Now, we know that in jump A, we essentially moved from layer 1 to layer 2, and then in jump B, we moved from layer 2 to layer 3. Well now, since we're currently in layer 3, we will be using the index of layer 3 as our initial index. And if you can guess it, the angle we're using here is indeed the angle we have calculated in our previous procedure. And you can see how repetitive this gets. It's very tedious, but you got to keep close track of your numbers, because it's easy to see how if you mess up a number up here, how it could essentially change the answers you get down here. Now, I did mention earlier, and I said it would play into this, how the index of layer 4 is just 1. Well, even though it's 1, and it technically wouldn't make a difference if I were to go ahead and place sine theta 1.3 and set that equal to what we have here, I will still include this in parentheses just for the sake of clarity and so you can better see our entire procedure at a first glance, or at a glance. So I will go ahead and still write this here. It just helps to clarify the problem a lot. And, of course, jot down theta 1.3. And with the power of a calculator, we can see that theta 1.3 is, in fact, 52.5 degrees. And if you're smart, you would have already figured out by now that since we've essentially run out of jumps, our theta 2 is in fact equal to theta 1.3. All these are equal. So our final answer is the angle here. And by final answer, I of course mean the final answer of the first portion of the problem. Now, just to reiterate or to clarify what we just did, given 4 different layers, each with their own index, if the initial beam comes in at an angle of 29.5 degrees, if initial theta is 29.5 degrees, and following our diagram here, and it comes in at 29.5 degrees from the normal, if you can imagine this dotted line, the normal, as 4 different dotted lines, well, 3 different dotted lines with layers between them, then the angle that comes out will be 52.5 degrees from the normal as our answer. Shows. Now, I did mention at the beginning of this problem that the second portion of this problem does reinforce our answer for the first if done correctly. And that is because the second portion of this problem is pretty much just doing this in backwards with an initial value. Now, the second portion of the problem does indeed give us the third and the fourth indices again, but we already know that, so we won't be jotting that down again. We already have it jotted down here, even if you can't see it. In fact, actually, I think I'll go ahead and jot them all down again, just so it's easier for you all to follow along with the problem-solving process. And I am writing these indices in the order of their subscripts, but we will be going backwards, so we'll be starting at index 4, or starting with index 4. Now, the second portion of the problem tells us, or asks us, given an incident angle theta 1, and you can think of this as a refresh. This obviously will not be the same theta 1 as the theta 1 we had in the previous portions of the problem, or in the diagram, of course. Just think of it as a brand new theta. But instead of traveling through the medium essentially from top to bottom, it'll be starting from the bottom. In other words, it'll be starting from the layer corresponding to index 4. Actually, let's see here. Oh yeah, there is a tricky aspect to this problem, and it's that it doesn't actually give you the incident angle. It wants you to find the incident angle, and given that the beam of light will have total internal reflection between the surfaces. Now, this is more of a, this requires obviously knowledge of concepts. We do know that in order for the beam of light to have total internal reflection, the angle, of course, must be 90 degrees. So our incident angle in this case will be something to find, not something given. Our given is provided to us by our knowledge of essentially the concepts, or the concept of reflection and refraction. So since we know that our beam of light must have total internal reflection between surfaces, our initial angle will in fact be 90 degrees. And it will have total internal reflection between indices 3 and index of 4. So I apologize if what I said earlier might have confused you about using all the, if I said anything about using all the indices and going backwards. We will be going backwards, but yeah, we'll see how this, I'll explain how as we go. But for now, the problem does repeat to us indices 3 and 4. So our initial, of course, will be an index 3. And since we are looking for the incident angle, our final answer will be an initial/incident angle. Something different you're going to see is that as we solve this problem, the thetas we want to find are actually going to be the initial thetas. Now, if we want to keep this consistent with how we solved the problem earlier, in this case, the theta you want to find here will in fact be theta 1.2. So essentially the third iteration of the initial theta. If you took the initial theta of the previous part of the problem and refracted it, I believe, twice, that would be the theta you get. But since we are working backwards, starting from layer 3, and we don't know the initial theta, which in this case serves as our final theta, in this instance we will be using what would have been the final theta for layer 3 as the initial, because we are working our way up through the indices instead of down. So if we, of course, plug in the index of 4, and given our knowledge of concepts, we plug in 90 degrees here. Let me just adjust this real quick. We will see that 1.2 in this instance will be 57.9 degrees. Now we are jumping up, so you can think of this as ascendance rather than descendance. I'm not sure if that's a word, but it's an ascent rather than a descent. Now we've just completed this ascent. Now we're on to the second ascent, the second arrow of this representation, if you will. So since our initials and finals have been switched essentially, although we are approaching 1.41, 1.41 will in fact be our initial index because we want to find the initial angle, which of course will be 1.1. We are counting down from 1.2. And using index 3 from our previous procedure on here, and using our calculated angle here, and of course with the application of a calculator or just a very smart brain, we will get theta 1.1 will be approximately 45.2 degrees. Now, onto our final ascent. We will be using N1. Now, I'm just going to pause here and explain why at this point in the problem, we know we are doing this correctly, because the second portion of this problem, what we're working on right now, it wants us to find the incident angle, essentially the beginning, the initial beam of light. So it only makes sense that in the final iteration of this procedure, we will be using the initial index because it corresponds to the initial beam of light and of course the initial angle that we wanted to find in the first place. So here, we want to find this, and of course it would correspond to the initial index. If this had been the second or the third, that either means you have more steps to go or you did something very wrong along the way. But we do know this serves as the initial index in the previous portion of the problem. This is what we want to find, and it is the incident angle. And if we take index of 2 and the angle we calculated in the previous portion of the problem, you will get a theta 1 value of approximately 38.4. Now, just to clarify what exactly our answer means in the context of this problem, 38.4 is the angle that the initial beam of light must be in order to have total internal reflection between the layers corresponding to N3 and N4, or indices 3 and 4. In other words, whichever layers these two bottom indices, the underlined ones, correspond to, the beam of light will have total internal reflection between them, so long as its initial angle relative to the vertical normal is 38.4 degrees. Now, this did go on longer than I had planned, but I hope it was a comprehensive and clarifying explanation as for solving a problem with multiple layers and multiple indices. Thank you.